Hello, greetings. This is the tutoring class, I guess, and today we are learning Pythagorean Theorem. In the description, I will put two videos. Eddie Wu explaining the Pythagorean Theorem. He's a really good teacher, and Khan Academy guy. I call him Khan Academy guy. He's really smart as well. So, today we're learning all about the Pythagorean Theorem. So the Pythagorean Theorem is very useful for maps test, many stuff like that. And you can get through a lot of challenging questions. For example, if there is 2 points on this plane, and all you have is those 2 points, and you want to find the length of this line, and you only have these. Well, now you have two sides that you can use. You have this side, A, and you have this side, B. So from there you can solve this problem. Today we are going to do that. So, who made the Pythagorean Theorem? So today, the person who made the Pythagorean Theorem was named Pythagoras. And the Pythagorean Theorem is the correlation between the three sides of a triangle. So, A, B, C. And we will soon know that this over here is the hypotenuse. I don't know how to spell hypotenuse. And then this one over here, there's A and there's B. There you go. But all you need to know is that this is a hypotenuse up here. Alright. So, the Pythagorean Theorem was first known in ancient Babylon and in Egypt. However, the relationship wasn't widely known until Pythagoras basically made it widely known. So, the formula. Here we go. The formula is a squared plus b squared equals c squared. And what we mean by a squared plus b squared equals c squared, let's make a triangle here. Triangle doesn't look like it can make a triangle, but we can make it out of this. There we go. We have a squared, and now this is a squared. A squared can be either one of these sides. It could be a squared over here or a squared over here. This is b squared. It can be either sides as well. But the only one that's c squared is the hypotenuse, c squared. This is c squared. You can switch them up though. So if you want a squared to be on the left side, and then you have to have b squared as the bottom right here. But if you want a squared to be on the bottom side, you have to have b squared on the left side. So that's the formula. A squared plus b squared is equal to c squared. And so then here we are going to try to find how it works. So here we go to the next slide, and here we see we have A over here, we have B over here. B is the longest side. Then we have A, and then we have B. We have A, and we have B, A, B, A, B. And if you notice, the length of one side is A plus B. So, okay, so remember the formula. The formula, we're actually going to solve problems now. The formula is a squared plus b squared is equal to c squared. Alright, so what is c squared what is A, what is B, and what is C? Let's just say C is always going to be the hypotenuse, the longer side. Now A could be either, and B could be either, but there has to be one each. So I'm just going to say this is A and this is B. It doesn't matter since the formula has a commutative property. So let's solve this problem then. What you do is you plug in the values. You're trying to find x right here. So what is A and what is B? So A is 4. So 4 squared, since it's A squared. B is 3, so 3 squared is equal to C squared. So first you do 4 squared, and 4 times 4 is 16, so 16 plus, what is 3 squared? 3 squared is 3 times 3, and that would be 9. So then 16 plus 3, or 16 plus 9, is equal to C squared. Now we add these two values together, and we get 25. 25 is equal to C squared. Now we're trying to find the value of C, not C squared. So the only way that you can take off that square is you take the square root of each side. When you take the square root of one side, you have to take the square root of the other side. So the square root of 25 is 5. So 5 is equal to C. So our answer is 5. And that's what I have been, this is why I say that it's a really good formula to learn, because if you look at the first problem, remember how I did like this kind of coordinate plane right here? And I wanted you to find the length of from this point to this point. Well, now you can do it, because if you make that triangle, well, now you can, this is 1, this is 2, and this is 3. So B is 3, and A is 3 as well. So if you're trying to find this point here, it's 3 squared plus 3 squared is equal to C squared. A squared plus B squared is equal to C squared. That's the formula. And when you do this, this is 9 plus 9 is equal to C squared. And then 9 plus 9 is 18 is equal to C squared. You take the square root of 18 and the square root of C squared, and if you take the square root of 18 out, that's 4.24. It's like a really long number, but there you go. You can find the length of that hypotenuse, that line. That is super, super, super cool. That is why we are learning this, because it's really, really important, and I love this formula. So let's go to the next problem. The next problem set 2. You have 2 and you have 10. Remember how we said that this was B and we said that this was A? So then A squared, let's write it out, A squared plus B squared is equal to C squared. That's the formula. So we know that A is 2, so it's 2 squared, plus we know that B is 10, so it's 10 squared is equal to C squared. So now we go over here and we actually simplify those squares. here. And when we do that, that's 2 times 2, which is 4. And we have plus 10 times 10, which is 100, is equal to c squared. Now, when we simplify these two values here, we will get 100 plus 4, which is 104, is equal to c squared. Cool. So when you take the square root of c squared and you take the square root of 104, usually maps testing to when you have something like this or a test, they usually just say the square root of 104 is equal to c. So that's our answer. Square root of 104 is equal to c. Now I hope that you're getting this, and I hope that you're understanding it, because this is pretty important and it's one of my favorite formulas. Alright, so now we go to problem set 3. So now we are actually provided the hypotenuse. Now you know that it's a hypotenuse because it's opposite from the right angle. And that is something else to mention. You can only use this formula for triangles that have right angles, or it won't work. It won't work. So you know that it's the hypotenuse because it's on the opposite side of that right angle. So the hypotenuse is 9, and we know that a squared, let's change the color. You know that a squared plus b squared is equal to c squared, and we know that c is the hypotenuse. So we also know that A or B could be one of these. Let's just say that it's A. I always choose that one, the shortest side that's not the hypotenuse, as A. So yeah, let's just fill in these values. So we got a squared, which is 4 squared, plus, we don't know, b squared? We don't know what b is, we're trying to find that, is equal to c squared, or 9 squared. Now, let's just simplify these two values. When we simplify those two values, 4 times 4 is 16, plus b squared is equal to 9 times 9, which is 81. Now, some simple algebra. You subtract 16. You subtract 16. And you subtract 16 on both sides, because if you subtract 81 from both sides, there's no equation anymore. So we're trying to keep the equation together. So subtract 16 and subtract 16, 81 minus 16. So 81 minus 16 is 65. So b squared is equal to 65. So then, the square root of b squared and the square root of 65, let's find the square root of 65. So that becomes a fraction. So let's just leave it as b is equal to the square root of 65, because it's round 8. 8 times 8 is 64, so it's around 8 and a little more. So I guess let's go to the next problem. Problem 4. Alright, now we have a triangle here. It's a normal triangle. We are trying to find the hypotenuse. Notice that it's a right triangle. It cannot be any other triangle. Obtuse, acute triangle? No, it has to be a right triangle in order for this formula to work. So, we're trying to find the hypotenuse, and we know that A, I'm just going to pick the shortest side, is 3, and B is 4. So then, let's just fill that into the formula. A squared plus B squared is equal to C squared. We know that A is 3, so we fill in 3 squared plus B is 4, so we put in 4 squared is equal to C squared. Alright, so now 3 squared is 9 plus 4 squared is 16 is equal to C squared. 9 plus 16 is 25 is equal to C squared, and square root of 25 is 5. Square root of C is C, so 5 is equal to C. That's our answer. Now let's go to the next problem. Find the value of x in the triangle shown below. Alright, so we have 13 and 12. We're trying to find the value of one, or the length of one of these legs. So that leg is the shortest, so I'm just going to say that that leg is A, and we are provided by the hypotenuse. We know this is the hypotenuse because the angle is directly opposite from there. So we also have 12, which is B, and we know that this is C. Let's put that into the formula. A squared plus B squared is equal to C squared. Alright, so we don't know what A is. We'll just separate that. And now we just have to do B and C. So we have B and C. So now we put in 12 as B. So A squared plus 12 squared is equal to 13 squared. Now, when we try simplifying that, we know that A squared plus 12 times 12 is 144, and 13 times 13 is 169, so is equal to 169 when we simplify these two. Next, let's transfer this 144 to the other side, so we subtract 144 from that side. Subtract 144 from the other side. We do this to isolate the A. We want to try to find the value of A, so we're trying to isolate the A. It's just like normal algebra, where you're trying to isolate the X or the Y or whatever variable you have. So you subtract 144, and I think that's 25 is equal to A squared. So you take the square root of A squared, you take the square root of 25. So A is equal to 5. Yay, you found the length of this side. And you know that you've done it right because the hypotenuse is always the long. It's not. I should have probably not worded it that way, but it's always the longest side for some reason. So in this example, we have 4, 3, and C is 5. It's longer than both of those sides. We have right here 9, 4, and we said that B leg was around 8, so yeah, it was longer. For some reason, the hypotenuse is always longer. If it's shorter, then there's something wrong. So yeah, that is the tutoring for today. I hope that this was informational. Put your comments down below of questions that you have, and I'll see you. Bye. Welcome to the Pythagorean Theorem, and this is Math Pie.